Okay, in this first screencast we're going to look at what makes an equation a quadratic equation. In other words, how do we know if an equation is a quadratic equation? In other words, an equation that creates a parabola. Well, probably the easiest way to explain this is that every quadratic equation must have an x squared term, and it can also have an x term and or an x to the power of 1 term and also an x to the power of 0 term. These two are optional, if you like. But it certainly must have an x squared term. So, for example, y equals 3x squared plus 0x to the power of 1 plus 0x to the power of 0 is a quadratic equation. Why? Because it has an x squared term there. Y equals 3x squared. Okay. Y equals 0.4x squared minus 3x to the power of 1 plus 0 times x to the 0 is a quadratic equation. Why? Because it has an x squared term. It also has an x term here, x to the power of 1, which of course is just x. So we could actually simplify this equation to 0.4x squared minus 3x plus nothing. And notice it's got an x squared term there. It also has an x term, and that's okay. So that's also a quadratic equation. Remember, the key ingredient's got to have an x squared term. Another example of a quadratic equation: y equals x plus 3 squared plus 2. That is actually a quadratic equation. Let's have a look why. What we can do is expand it to see this. So we can rewrite this as y equals x plus 3 times x plus 3 plus 2 on the end. Okay. Now, because we've got two brackets multiplying together, we can multiply them using FOIL. The first two we multiply together, then the outside two, then the inside two, and then the last two. So if we do that, we're going to have y equals, the first two is x times x, which is x squared. The outside two, which is x times 3, is 3x. The inside 2, which is positive 3 times x, is also 3x. And the last 2 is positive 3 times positive 3, which is 9. And don't forget the 2 on the end. So if we simplify that, that's going to be x squared plus 6x plus 11. That is a quadratic equation. Why? Because it's got an x squared term. It's also got an x term and an x to the 0 term. Remember, x to the 0 equals 1. So 11 times x to the 0 is just 11. So all of those are examples of quadratic equations. What's not a quadratic equation? Well, let's have a look at some examples that people might think are quadratic, but they in fact aren't. Y equals 1 over x squared is not a quadratic equation. Why? Because if we rewrote that correctly, or actually if we rewrote that in index form, we would write that as y equals x to the power of negative 2. Because the power, the x squared term is on the bottom of the fraction, when we bring it up to the top, it becomes a negative power. So x to the negative 2 is not x to the power of 2. Therefore, that is not a quadratic equation. Y equals x squared plus x to the power of negative 1. You might think that is a quadratic equation because it's got an x squared term. but it's actually not a quadratic equation because it also has another term here, which is x to the power of -1. In other words, a quadratic equation, it must have an x squared term. It can also have an x to the power of 1 term. It can also have an x to the power of 0 term. It cannot have any other type of x term. This was x to the -1. That is not allowed. Therefore, it is not a quadratic equation. So a quadratic equation, to cap off or to summarize, must have an x squared term in it. It can also have an x term and an x to the 0 term, but it must have x squared, and it cannot have any other type of x term other than those that are described there. Thank you.